Hello, folks. Welcome, welcome, welcome. Let's see if we can figure out who actually solved the crime. Here we go. Real quick, solve the murder. Watch carefully.
Clearly, somebody in this room murdered Lord Smythe, who, at precisely 3:34 this afternoon, was brutally bludgeoned to death with a blunt instrument. I want each of you to tell me your whereabouts at precisely the time that this dastardly deed took place.
I was polishing the brass in the master bedroom.
I was buttering his lordship's scones below stairs, sir.
I was planting my petunias in the potting shed.
Constable, arrest Lady Smythe.
But how did you know?
Madam, as any horticulturist will tell you, one does not plant petunias until May is out. Take her away. It's just a matter of observation. The real question is, how observant were you?
Ready for your brain to get exploded here. I got like two of these, maybe.
Clearly, somebody in this room murdered Lord Smythe, who, at precisely 3:34 this afternoon, was brutally bludgeoned to death with a blunt instrument. I want each of you to tell me your whereabouts at precisely the time that this dastardly deed took place.
I was polishing the brass in the master bedroom.
I was buttering his lordship's scones below stairs, sir.
I was planting my petunias in the potting shed.
Constable, arrest Lady Smythe.
Okay, so there we go. Good point. It's easy to miss something when you're not looking for it, and it's a very good point. There we go. So we're going to get rid of this. Let's go back to where we were and move this over here. Okay. So one of the things we're doing is talking about observations and conclusions. And let me tell you, in science, this is like really, really important because a lot of times we don't know what really it is that we're looking for. So what we're going to do is to cover the basics. An observation, maybe you've had this, maybe you haven't. It's any data or facts gained by our five senses. In science, instruments can extend our senses. These instruments allow us to have observations in greater detail. Now, one of the things we need to mention, which I should have said at the beginning, make sure to print out the PDF of this and collect your guided notes. If you take a look here, for instance, and someone were to ask, well, what do you observe right here? I could say I observe that there appears to be a blue sky. There's some clouds. There's green vegetation. It appears that there's a hill in the distance. Could I say that it's hot or cold? Not really, because I have no sense. It could be a very clear, extremely cold day. That would be more of a conclusion. Now, with observations, a couple things is that our instruments we use in science help to fine-tune our senses. Okay, and so we have to be very careful how we use those instruments and agree on those instruments. And then we're going to get into something called quantitative and qualitative data. Quantitative data would be anything that involves a number and a label. So as an example, if I say it's 15 degrees Celsius outside, that would be sort of quantitative observation. It's giving us a greater degree of hot or cold. If I just say it's hot or cold, that would be a qualitative observation. Units and labels are extremely important. You're going to hear me say this a million times. No naked numbers. 15 degrees. Is it 15 degrees Kelvin, which is 15 degrees above absolute zero? Is it 15 degrees Celsius, which would be like cold water, or 15 degrees Fahrenheit, which would be below freezing? So we have to be really careful. If there's no units and labels, doesn't count. Okay. So here we could say the kid is sick. That's a conclusion. We could say the child has his hand on his head or her hand on his head. Hard to tell if it's a boy or a girl. Probably a boy. This right here would give us a indication of a quantitative measurement of their temperature. Could we infer that they have a fever from that? Maybe he put something hot in his mouth just before he put it in there. That's why we need to be careful with observations and conclusions. Now, a conclusion is an inference that's based on observations and background information. Something that's extremely important when we answer questions in science where we're talking about a conclusion is you have to do 3 things. I would strongly encourage you to write this down. Number 1, provide the answer. What's the conclusion? Number 2, you have to provide some type of data and or some type of background information. If I'm looking at this picture right here, I could, a conclusion would be the crowd is angry. They're lifting their fists in the air. That would be an observation. And some background information would be this was taken at a political rally. That might be enough for a conclusion. There would be things I would have to add to it. Who knows? Or if my background information is wrong, maybe this is at a sporting event. Maybe they're cheering a touchdown or a goal or something. I don't know. But a conclusion is much different than an observation in that you have to have background information and data to support your answer. And I'm going to be hitting that theme over and over and over. So basically, here's your homework. Here's a murder scene. We think, again, is that a conclusion or an observation? Well, here's what you need to do. Indicate 5 observations. Tell me if they're quantitative or qualitative. And then see if you can come up with 3 conclusions. And when you provide your conclusions, make sure to include support. Every teacher's going to tell you that, especially when it comes to short answer test taking. You need to put support there. Conclusion, anytime you come up with an answer, again, data and background information as well. The next thing you'll need to do, you'll have some notes here that you can do it on. And finally, for your take-home experiment, one of the things you'll need to do is to either boil some water, light a candle, observe for 5 minutes, provide 5 observations and 3 conclusions. There you go. Have a great day.